This is a right triangle, and it means that one angle in the triangle is 90 degrees. And remember, just for later, that when you add up all of the angles inside of a triangle, you should get 180 degrees. So in this case, that means that the other two angles are together. When you add them together, you'll get another 90, right? So you've got a total of 180 degrees in the triangle. Anyway, let's get rid of that. I don't want that really. Whoops. But I want that. How can I make it smaller? Maybe like that. Yeah. Okay. And so let's look at the other angle. Let's label it first. So we'll always label it the same way. For the right triangles, we usually like to have big C for the vertex at the right angle, and then the other two, we can make them whatever. So you can have it A and B. And that's how we label with capital letters the vertices, the points at where the two sides meet, the two edges meet. And then, so now sides are going to be lowercase letters. So little a will be opposite angle big A. Little c is always the hypotenuse, the longest side of the right triangle, and little b is the opposite big B. So in trigonometry, somebody figured out some relationships between sides and angles a long time ago. So the first one that we can talk about is the sine, which is S-I-N-E, but actually we don't write the E normally. So the sine, a trig function called the sine of angle A is equal to, and later on we'll put numbers in places here and stuff, but we call it opposite. So you can even write it opposite over hypotenuse, okay? And in this case, that's going to be equal to the little baby or lowercase letter opposite angle A. So if we're standing at angle A and the A is to our back and we're looking out into space, the opposite side in this triangle for us to angle A is side A. So opposite, and then the fraction, and on the bottom is the hypotenuse, which is the longest side, which is the little c. So the sine of angle A is equal to side A over side C. The cosine is another one of angle A is equal to the adjacent ADJ, the adjacent side to angle A over the hypotenuse, and we'll just put HYP, which is equal to the cosine. Obviously the hypotenuse is this little c, but on top, the adjacent for the cosine angle A, the adjacent, is not the opposite side, which is the little a, right, as we pointed out before, and it's not the hypotenuse, so it must be the b. So the little b, which you can't really see very well here, but I'm going to make it a little nicer, the little b, and the tangent of angle A is the opposite over the adjacent ADJ, adjacent side, which is little a over little b. And later on, you might need the other trig functions. So there are three more. The opposite, the upside down or the inverse trig function to the sine A is the cosecant A. And that's just flipping over the fractions that we got on the left-hand side when we did this. So I'm going to put a little c over A, and the cosine has the secant, and you don't need to care what that really means right now, but you just need to care that it's the flipped over version of the cosine, and the cotangent is the flipped over version of the tangent. Cotangent A would be equal to the adjacent over the opposite, the b over A. And those are your 6 trig function relationships in the triangles. Later on, we'll just put numbers for the little a and c, and for the angles, degrees for the angles, and we'll try to get something alone and solve them.